For this particular presentation, we're going to talk about emotions and memory and the link between emotional and memory-based behavior and the neurobiological roots of them. So in physiological psychology, we know people are very good at memory things. We know people have a lot of emotions on things. What a neuroscientist would care about is the idea of, can we actually figure out where in the brain all this stuff is actually occurring? Can we actually reduce things? The idea of reductionism, from looking at how memories are formed mentally or emotions are formed mentally at a mind level, to the neurobiological pathways in the brain and the things going on neurobiologically. So I have three little bits here to share with you. The first one is some very famous research. He's been doing this research for a long time. Chapter 12, Joe Ledoux has done this research. So let me describe kind of the simple experiment that he does, the result, and then kind of the implications of it. So the method is very simple. You take a rat per se, and you put a rat in a operant conditioning chamber, kind of a Skinner box where it has a grid under it. And what you do is you turn a tone on, and let's say you turn the tone on for about 10 seconds, and then you deliver a foot shock to the grid. So the animal kind of jumps up when it gets the foot shock, and then the two big responses the animal has. One is the freezing response. After it jumps, it comes down and it kind of is staring around the cage, if you can picture a rat doing that, kind of just frozen per se, and you see a big increase in the heart rate and the blood pressure for the rat as well. So that's trial one. You have a tone, then you have a foot shock, and then you have the freezing response with the increase in heart rate and blood pressure. Now, the question that Ledoux was interested in looking at is what would happen if you started doing this for numerous trials. You turned on the tone for 10 seconds, and then you delivered the foot shock. Well, what seems to occur is when you start turning on the tone, the animal, as soon as you turn on the tone, after doing this for a few trials, starts having the increased heart rate and blood pressure and the freezing response as soon as you turn on the tone. And so if you know anything about operant and classical conditioning, you know this is an example of classical conditioning. The tone starts off as neutral, but after a few trials where the tone is then paired with the foot shock, the animal learns the tone is going to predict it, so the tone becomes the conditioned stimulus, and when the tone is on, you have the freezing and increase in heart rate and blood pressure. That becomes the conditioned response. So that is called classical conditioning. The name of this classical conditioning setup is called the conditioned emotional response. So many times we can take this even to human analogies, that if you know something as bad is about to happen and there's something neutral to begin with, you kind of get upset and scared and have the freezing response and the autonomic arousal just on the basis of the tone coming on here. So that's what was done in the first situation. What was really interesting for the Ledoux research, though, kind of the part two of the neuroscience, is he wanted to figure out what was going on in the brain. And so he started doing a lot of research on this, and what he was able to figure out, and kind of the key neuroscience end, emotional response, the fear response, seems to be all predicated on a structure in the limbic system called the amygdala. As we know, the amygdala is really involved in a lot of emotional behaviors. And what he was able to find out is, after he did this for a number of trials, he was able to actually find out that there are actually some direct brain connections that really set up this whole classical conditioning thing. When you hear a tone, when it's processed, as you're listening to my acoustics right here, is being processed in an area of the brain called the thalamus. It's actually an area of the thalamus called the medial geniculate nucleus. So the medial geniculate nucleus of the thalamus actually has a direct connection, Ledoux was able to find out, to the amygdala. So the thalamus actually has a direct connection to the amygdala. So one part of the conditioning, the idea of hearing a tone and remembering it and having the emotional response, seems to be predicated on this particular pathway, this neuroanatomical pathway between the thalamus, the medial geniculate nucleus, and the amygdala. And so when you cut that connection, you kind of lost the conditioning per se. So there's a direct connection that can explain the classical conditioning going on. The other connection was also very interesting. There's a connection directly between the hypothalamus and the amygdala as well. So the hypothalamus might actually explain this idea of the increased heart rate and blood pressure. So the increase in heart rate and blood pressure might be due to the connections between the hypothalamus and the amygdala, because when that was cut, you kind of lost that fear conditioning with the increased heart rate, the autonomic arousal. And then finally, there's a third connection as well. I should have said this to begin with. That's actually a connection from the periaqueductal gray. The PAG, the periaqueductal gray, and that connection between that and the amygdala seemed to be the part that was causing the freezing response. So when an animal was having the freezing response is kind of a flight or fight type situation, and when you cut the connection there between the periaqueductal gray and the amygdala, you seem to lose the conditioning for the freezing response. So this is the nature of Ledoux's research. The reason people care about this so much is you've seen people who get classically conditioned to be fearful of things. And his research is very reductionistic. He's been able to find the neurobiological pathways that seem to cause this. The tone and the sound seems to go very directly from the medial nucleus of the thalamus right to the amygdala. And of course, the hippocampus is right by for memory. In another part, the increased heart rate and blood pressure seems to be due to a connection between the hypothalamus and the amygdala as well. And he's done a lot of research in the amygdala. It's actually called the basolateral nucleus in the amygdala. And finally, the freezing response is the periaqueductal gray relationship with the amygdala. So Ledoux looks at this conditioned emotional response and looks at the classical conditioning that's involved there, and then he's actually been able to do this reductionistic type of thing to isolate the neurobiological pathways, the neuroanatomical pathways that seem to cause this. So if you're ever working with somebody who has like post-traumatic stress disorder or something else, and you're thinking what's going on with them behaviorally, then you can almost be sure that there's also something going on with the classical conditioning in the amygdala and its related connections. Thanks.